metals. That can be something like iron 2 plus. That means on your ion chart, it's going to look like Fe with a Roman numeral number 2. And I can't do that without zooming in, so I'm going to zoom in. Okay, so it's going to look like iron 2. And the reason why that's important is because there's also an iron 3 plus, which looks like Fe Roman numeral 3. Okay? And they form different compounds. So let's say we had iron 2 sulfide. Okay. So that would be your Fe 2 plus and your S 2 minus. So knowing your rule of zero charge, your formula would just be Fe S, because you've got 2 plus, 2 minuses, they cancel out. But if you have Fe 3 plus and S 2 minus, then they don't cancel out, right? So you're going to have Fe 2 S 3. And that's going to be named iron 3 sulfide. So what if you're just given the name iron 3 sulfide? How are you supposed to know that? So remember when I gave you the little crisscross method? Like if you have Fe 2 S 3. Well, that's also helpful in reverse, because you can say, okay, if I have Fe, that means my charge must be 3 plus, because that's coming from here. And if I have S, my charge has to be 2 minus, because that's coming from there. So that can really help you out with your transition metals. Okay, so if you have more questions, I will put a video about transition metals on Schoology. Oops, I'm going to keep on going with the answers to the packet here. All right. So all you need here is your ion chart. So Mg and Cl, so we always write the metal first. So the name of the metal is magnesium. And then we look up, which is this, magnesium, even though it's an ion. And then we look up the name of the nonmetal, which is on our ion chart, and that's in the other column, and that is chloride. And then we need to make sure that the charge balances out. So we need, Mg is 2 plus, as you can see. So we have 2 positive charges, so that means we also need 2 negative charges. That's why we draw it like this. And when you add that together, you've got 2 positives, and you've got 2 negatives. Okay, so when you add that together, that's 0. So your formula then is MgCl2, because you have 1 Mg and 2 Cl's. So I'm not going to go through all those steps again. I'll still explain it, but again, we've got our metal. Look on your ion chart. The name of the metal is lithium. The name of the nonmetal you can find is sulfide. Okay, so let's write out our charges. We've got Li plus, we've got S2 minus. Right now, those charges don't add up. We need another positive. Now we've got 2 positives. We've got 2 minuses. Those add up. That's good. So we can say our formula is Li2S, because we need 2 Li's, 1 S for it to add up to 0, the whole charge. Sodium. Did you hear the guy who wanted some sodium? He said, nah. Alright, so we got some sodium, and we've got oxide. O, find it on the other side, it's O2 minus. So we got Na, not 2 plus, I just wrote it, Na plus, and we have O, 2 minus. So you can see that those don't add up, so we need another Na. Okay, so now we have 2 total positives, 2 total negatives, and we write the formula. We have 2 NAs, so that's Na2 and O. Calcium, you can find calcium on your ion chart. Ca2+, and then nitride is N3-. It's like nitrogen. So we've got Ca2+ N3-. Okay, so those don't add up. Even if I add another one, I still have 2, and then I have 6. One way I can get this, I can't, if I had another one here, I would have 9, and there's no way I can add factors of 2 to get to 9. So, but if I add another calcium, miraculously, now I have 6 positives, I have 6 negatives, and my formula is Ca3 and 2. Potassium sulfide, we got a little K+. Don't you love doing these videos? Okay. Alright, then we got S2-, and then maybe you're going to see a pattern here. It's just like Li and S2, because K is +1, K plus, S2-. Need another K. Now we have 2 total positives, 2 negatives, and we have K2S. So if you look at it, here's what I was talking about. Okay, same positive charge there, same positive and negative charge there. Overall, you have 2 of the positive ion, 1 of the negative ion. Okay, that's part of the property, the periodic property of being in the same family. They have the same ion charge. Alright, Be, beryllium. Beryllium. And then we got bromide. Alright, so Be is 2+, and Br is -1. So that's kind of the same as the first one. So we need another Br-. So now we have Be, Br2. Okay, so if you add those up, 2 positives, 2 minuses. Okay, so this is very similar to this guy right here. We had Mg2+, Cl-. Now we have Be2+, Br-. Same kind of formula because the ions have the same charge. Alright, Sr2+, P3-. This is just like our calcium nitride problem. Alright, so we've got Sr, strontium, and P is phosphide. Alright, so we need Sr2+. Start with what you're given, and then you just keep adding as long as they don't add up together. So that way eventually you get a total charge that balances out to 0. So we've got strontium, we need 3 of those, and then we need 2 of our phosphates. Rubidium iodide. RB. I'm going to have to look this one up because I believe it is +1. But I'm just going to double check so I do not lead you astray. And iodide. I know it's either in the 1 or the 2, and I'm going to consult my trusty online periodic table. And remembering where things are on the periodic table, RB, okay, it's a plus 1. Since I know RB is in the first column, I know that it only loses 1 electron, so it's an RB plus 1. Oh, I wrote that totally in the wrong spot. Just kidding. Okay, RB plus 1, and then K is, wow, I is minus 1. So they already cancel each other. Well, they cancel each other out. And sometimes you might find things that are on your ion chart. I mean, on this chart, but they aren't on your ion chart. So you have to remember, if it's in the first row, like rubidium, it loses 1 electron. If it's in the second row, like beryllium, it loses 2 electrons. So that's why it becomes a 2 positive. So this is just going to be simply RBI. Just like a baseball, who's got the most RBIs on the Cubs? I don't know, but I bet one of you do. Alright, strontium fluoride. We've got SR 2 positive, again. Fluoride, F minus. We need SR2 plus, F minus. Those don't add up. I need another F. Okay, so now I've got 2 positives, 2 negatives. So I've got SRF2. So notice I put the little 2 after because that tells me how many of these F's I have. I have 2 F's and I have 1 SR. Aluminum sulfide. Okay, Al 3 plus, sulfide S2 minus. So Al 3 plus S2 minus. Another pattern with when you have a 3 and a 2, you're always going to have to end up with 6 as what you're trying to add up to, because that's the, oops, not 2, what did I just say? 6. Because that's the that's the least common multiple, greatest common factor, I don't know, one of those things. That's the only thing that they're going to be able to add up to. So 2 and 3. So we're going to have Al2S3.